Okay, so yesterday we just had a look at Le Chatelier's principle that we have three types of stresses. We have concentration, we have a change in temperature, and we have a change in pressure. Okay, so if we increase or decrease, okay, so concentration, if I increase my concentration, equilibrium shifts to the opposite side. If I decrease the concentration, the equilibrium shifts to the same side. Temperature, if I increase my temperature, it's going to shift to the endothermic side, whatever that side is. And if I decrease the temperature, it's going to shift to the exothermic side to produce heat. And finally now we're going to have a look at pressure. So I didn't have a look at this with you. So just here, if we have A a gas and B as a gas as my reactants in equilibrium, and we'll just say with C. Now I'm just going to put 2B and 4C here just because that's what I've done in the notes. First thing to state about pressure is that it only works or counts if the whole system is a gaseous system, so both the reactants and the products are gases. If I look here, I have one molecule of A and two molecules of B. So I have 3 molecules on my left hand side, and on my right hand side I have 4 molecules. Okay? If I increase the pressure, it always favours the side with the fewer molecules. So equilibrium will always shift to the side with fewer molecules. So in this case, if I increase my pressure, it's going to favour the left hand side, so equilibrium will shift left. Okay? If I decrease my pressure, it's going to favour the side with more molecules. So my right hand side in this one has 4 molecules, so if I decrease it, it's going to favour my right hand side. Again, this is very important in industrial applications because by increasing or decreasing the temperature, the pressure, I can end up with more of my product being formed. Okay? As I said, always only gaseous, so when I increase my pressure, it always favours the side with the fewer molecules, and if I decrease the pressure, it's going to favour the side with more molecules. Okay, so they are your 3 stresses that can be applied to a system at equilibrium. Just why the pressure only affects a gaseous system. If you look at your particle theory, so if we have a solid here and a liquid, okay, so they're a little bit further apart. And finally then, if we look at a gas, they're very widely spaced apart. So if I have a change in pressure here, it's not really going to have much of a difference because in a solid the particles are packed tightly anyway. Likewise with a liquid, if I increase the pressure, but if I increase the pressure here, it is going to have an effect on the particles because they're going to have a much smaller volume now in which they can move. You don't need to know that, but it's just an explanation really as to why it only has an effect on gaseous molecules. So this is important here.